Hello students, welcome to our channel Diksha Karnataka. As we have already know that we have started two series where we are discussing the important topics in a chapter and then we are solving 30 important questions from this chapter, right? So we have already done that for solutions chapter. The next turn is of another high weightage chapter, that is chemical kinetics. So in my previous video, I have discussed what all concepts you have to revise from the chemical kinetics chapter so that in this less time you can effectively cover this chapter. So in today's video, I'll discuss top 30 questions of chemical kinetics. So these questions are very much similar with your KCET previous year questions from chemical kinetics. So if you are able to do these questions, you can assure yourself that you are very thorough with the chapter and you can crack all the questions from this chapter coming in your exam, right? Okay. So let us see this. Okay, and before this, in my last video, I have discussed top 30 questions from solutions chapter. I went through the comments that you have posted and I saw some doubts you have. So first let me clear those doubts, then we'll go with the kinetics chapter, right? Okay, so one question that you people have told is doubt is when the pure solvent diffuses out of the solution through the semi-permeable membrane, then the process is called. Yeah. So I think the answer for this I told osmosis. Actually, you have to read the statement little carefully. Pure solvent diffuses out of the solution. Okay, so from the solution, the solvent is going out. So the correct answer for this will be reverse osmosis. Okay, so that is one. Next is 5.5 milligram of nitrogen gas dissolve in 180 gram of water at 273 Kelvin and 1 atm pressure due to nitrogen gas. The mole fraction of nitrogen in 180 gram of water at 5 atm nitrogen pressure is approximately. So this one I have told you, this is question from Henry's law. So what they are telling is we can use this formula. P1 is equal to KH into X1 and P2 is equal to KH into X2. Right? So now if I take the ratio P1 by P2 is equal to X1 by X2. Now let us understand the question. What is telling when the pressure is 1 atm, how much nitrogen gas was dissolved? 5.5 milligram. Now the question is asked if the pressure is increased to 5 atm, then how much mole fraction of nitrogen will dissolve? Okay, that is what we have to calculate. So now let us calculate X1 value. X1 is equal to number of moles of nitrogen divided by number of moles of nitrogen plus number of moles of water. So as you know, this number of moles of nitrogen is very less as compared to the number of moles of water. So we can ignore this part. Then if I calculate the value for number of moles of nitrogen, it is 5.5 into 10 to the power of minus 3 gram divided by 28 whole divided by number of moles of water. You can see 180 gram, 180 by 18. So that is your 10. So this value, if we solve it, that will give you the number of moles of nitrogen, the mole fraction of nitrogen. So I'll get 0.196 into 10 to the power of minus 4. Okay. So this one value we'll get for X2. Now we can substitute here 1 by 5 is equal to X1 is your 0.196 into 10 to the power of minus 4 and we have to calculate the X value. So now if you solve it, we will get X is equal to this 0.196, we can approximate it to 0.2. So 5 into 0.2 is 1 into 10 to the power of minus 4. Okay. So the correct answer for this question will be option D. Okay. So like this, you please solve it. Any doubts you are getting, comment down. I'll surely address them in my next video. So now we are done with the solutions. We'll go to the chemical kinetics important questions. So first one is, the question is from rate law. I have also divided these questions based on the topic so that we can know which topic has to be focused more. So first topic is your rate law. The rate of gaseous reaction in the expression KAB square, if the volume of the vessel is reduced to 1/2, the volume of the reaction rate as original rate is dash. So first of all, we have to know what is the relation between volume and concentration. So we know concentration is equal to number of moles by volume. So when volume decreases, concentration will increase. Okay, and vice versa. So what they have done here, the volume is reduced to 1/2. So the concentration will double. Now we can easily write down the rate law. R is equal to K into AB square. Right. Now since the volume is double, volume is reduced to half, concentration will be doubled. So I can write all the values as 2A and this one as 2B whole to the power of 2. So now if you solve this, we'll get 8 times of K, A and B to the power of 2. So you can see, suppose this is my final rate. So I can write rate dash is equal to 8 times of initial rate. So the correct answer for this question is option C. Okay. So this is very direct and easy question. You will get similar questions from rate law. Now next question, for the elementary reaction 2A plus 3B gives 4C plus D. The rate of appearance of C at time t is 2.8 into 10 to the power of minus 3 mole liter second inverse. Rate of disappearance of B. This is the first topic from chemical kinetics where we learn about differential rate law, right? So very easy question. You have to be little careful while writing the equation. And one tip here, you do not write the whole equation. Okay, you write down the equation for those quantities which is asked in the question. So the question is asking us about B and C. So let us write the relation between B and C. Minus 1 by 3 dB by dt will be equal to 1 by 4 of dC by dt, right? So now let us calculate, we have to calculate the dB by dt. So dB by dt will be equal to minus 3 by 4 dC by dt. And the dC by dt value is given to you 2.8 into 10 to the power of minus 3. So the correct answer for this question will be option A. Now you'll be thinking here minus is there, but in option it is not given. So when they have already told that rate of disappearance is there, that means the concentration is decreasing. So the rate of disappearance is 3 by 4 of dB by dt, right? So this is also easy question. You will get many questions of this type. Okay, now again rate law question. 1 liter of 2 molar acetic acid is mixed with 1 liter of 3 molar ethyl alcohol to form an ester. The rate of the reaction with respect to the initial rate when each of the solution is diluted with an equal volume of 1 water will be. Okay, so first, what is this 1 liter 2 molar? Means 2 moles are there in 1 liter. So can I write the initial rate law as K into concentration of acetic acid as 2 by 1, where 2 moles are present in 1 liter. And for concentration of ethyl alcohol, I can write 3 by 1. Okay, so this is the initial rate. Now what has happened? The new rate is, suppose let us add equal amount of water, means let us add 1 liter to both the solutions. Okay, you can do, and you can take any quantity. Now if I add both the solutions by 1, so this will become 2 by 2 and this will become 3 by 2, right? The volume will become twice. Now what we can do, just take the ratio of these two. So if I take R by R dash, we can get 2 by 1 into 3 by 1 whole divided by 2 by 2 into 3 by 2, right? So if I solve this, R by R dash, I will get 4, right? So now what is R dash value? R dash value is R by 4, or I can write 0.25 times of the initial rate. So the correct answer for this question will be option A. Okay. Next, again from the differential rate law question, first of all write the reaction properly, disappearance of O2 and the appearance of SO3. So you just see what two reactants or two elements that have been related. So I can write here minus dO2 by dt is equal to SO3 is 1 by 2 of dSO3 by dt. So we need to calculate this one. So I can write minus 2 dO2 by dt is equal to dSO3 by dt. Okay. So minus 2, what is dO2 by dt? That is 2 into 10 to the power of minus 4. So I will get 4 into 10 to the power of minus 4. See, there are students of different categories. This much you do not have to solve in the exam. But for everyone to understand, I am solving in so much detail. You can just skip and you can write down the values and get the answer in quickly. So the correct answer for this question will be option B. Okay. Next. Again a differential rate question. For the reaction 1 by 2A gives 2B, the rate of disappearance of A is related to the rate of appearance of B by the expression. Here the question is little tricky because it is 1 by 2. Okay, so what I have to do is minus of 1 by 2 dA by dt will be equal to 1 by 2 of dB by dt. Okay, So now if I make this one, I'll get minus 2 dA by dt is equal to 1 by 2 dB by dt, right? So we will get dA by dt as 1 by 4 of dB by dt, right? So the correct answer for this question will be option A. Okay, easy one. Next, which of the following statement is incorrect? Okay, molecularity is only applicable for elementary reaction. This is a correct statement, right? We know molecularity is always applicable for elementary steps. So statement A is correct. Now let us see the next statement. The rate law for any reaction cannot be determined experimentally. This is incorrect. The rate of any reaction is determined only and only experimentally. Okay, so the incorrect statement is option B. So the answer for this question is option B. Let us check the other options. Bimolecular reactions involve simultaneous collision between two species. That we know. Bimolecular means it will include two species. Complex reactions can have fractional order. It is also correct because it has many steps. We can get fractional order for complex reaction. So that is why statement B is the incorrect one. Now let us see quickly this one. Again, rate law. For a chemical reaction, Ma gives Xb, the rate law is given by RKA square. If A is double, the reaction rate will be. Very simple one, R is equal to K into 2A square. So if we L will get 4 times of Ka square. So what is the new rate? I can write, this is my R dash. R dash is equal to 4 times of R. So the reaction has quadrupled. The rate has quadrupled. So the correct answer is option B. Easy one. Next. dB by dt, again a differential rate law question, minus 1 by 3 of dA by dt is equal to 1 by 2 of dB by dt, right? So dB by dt will be equal to minus 2 by 3 of dA by dt is equal to dB by dt, right? So we will get minus 2 by 3, that is your option B. Correct answer is option B. Next. Okay, this question is very similar to the one which we have already solved. 100 ml 1 molar was mixed with 100 ml 2 molar ethanol. The change in the initial rate, each solution is diluted with equal volume of water, right? Okay, so again we can do the same thing. So we have the R is equal to K into concentration of acetic acid will be 1 mole in 100 ml into 1000, okay, divided by here 2 moles in 100 into 1000. Now what they have done is we have increased the volume. So I can take it 200 and here also I can make it 200. Okay. So now if you take the ratio of these two, we will get R by R dash as 4. Okay. So R dash will be equal to R 1 by 4 of R, that is 0.25 times. This question I have already solved it. So you can just check once again the correct answer for this option B. Okay, next. In which one of the following reaction the rate constant has the unit of this one? Okay, so this question, to solve such questions, the thing is you should know the how to write the unit of rate constant for any nth order reaction. So that is K is equal to mole 1 minus n liter n minus 1 second inverse. Okay, so what you have to do is you have to equate the power of mole given in the question to the power of mole to the general equation. So what is the general equation power of mole? 1 minus n, and here it is 1. So can I write 1 minus n is equal to 1? Then what will be n value? N value is 0th order reaction. So this is the first part of the question. So what we can say is the question is directly asking us to find which of the following options is a 0th order reaction. So it is in an indirectly way it is asked. So we have acid catalyzed, this is our first order, CHCl3 is first order, NO is also first order. You know, decomposition of HI on the surface of the gold is a 0th order reaction. So the correct answer will be option D. Now you will be thinking how to know which order these reactions are. So go to the NCERT book, you can see for every order there are some examples given and the questions will be from those examples only. So revise those examples. At least you should know 2 or 3 reactions for 0th order and first order. Okay, you have to remember those examples so that you can do such type of easy but theory based questions. Next. Okay, the rate of the reaction is given to us for any ester and NaOH is giving you this one plus this one. the rate of the reaction is given by the concentration of ester and NaOH. If the concentration is expressed in mole liter inverse, the unit of K is. Okay. So first of all, let us find the order. So what's the definition of order? Order is the sum of the power of the concentration terms. So can I say here the power is 1 and here the power is 1. So if we add them, the order will be 2. So n is equal to 2. Now if you find the unit of K, it is, I just told you the formula, mole 1 minus n. So 1 minus 2, liter n minus 1. So 2 minus 1. Then second inverse. So I'll get mole minus 1, liter 1, second inverse. So the correct answer for this is option A. Okay. This is also easy question. Next, for a reaction A plus 2B products when concentration of B alone. Okay. This question you have to pay little attention and you have to understand the meaning. When the concentration of B alone is increased, the half-life remains same. So what is it telling? B concentration is increased and T half is same. Okay, next let us read the next part. Concentration of A alone is doubled. So A concentration is doubled and the rate remains same. Okay, now you should know some basic things that for first order half-life, it doesn't depend on the initial concentration. Whatever initial concentration you check, the half-life will remain the same. That is why if T half is remaining same for any concentration, we can say that B is a first order reaction, or with respect to B, the reaction is first order. So I can write any rate like this. Okay, now what is told about A? Whatever concentration you increase, the rate remains same. So the rate will remain same only if it is a zeroth order reaction, right? So that is why it will be A to the power of 0. So what is the overall order of the reaction? 1. For 1, what will be the unit? Again I told mole 1 minus n. So 1 minus 1, liter n minus 1. So 1 minus 1, second inverse. This will be 0, 0, 1. So we'll get second inverse, and the correct answer for this question is option A. Okay. Next, this one I'll tell little tricky question because we have to understand here something. So the value of rate constant of pseudo first order reaction. Okay, listen first thing. The rate constant always depends only on temperature. Okay, rate can be dependent on concentration, temperature and all, but rate constant depends only temperature. So the correct answer here will be depends only on temperature. You need not think these things depends on the concentration of reactants present in small amount. This is for rate, but the question has asked for you rate constant, which is only and only dependent on temperature. So correct answer will be A. Okay, so this one you have to know. Okay, now we'll go to the another topic, that is integrated rate law. Here you should remember the formulas for zeroth order and first order reactions. Now, if the rate constant of a first order reaction is K, the time T required for the completion of 99% of the reaction is given by. First, let us write the integrated rate law. K equal to 2.303 by T log of A naught by A, right? Now I know for 99%, whenever percentage is given, take the initial concentration as 100. So I can write T equal to 2.303 by K log of 100 by A. See, 99% is completed. Then how much reactant will be left? 1%. So I can write it as 1. So what I will get? 2.303 by K log of 10 to the power of 2 we can write it, or we'll get 4.606 by K. So the correct answer for this question will be option A. Easy, direct based question. Just you see there's no calculation involved also. Okay, you have to just write the expression. Next, the time required for 60% completion of the first order reaction is 50 minutes. The time required for 93.6% completion of this reaction will be. Okay. So here you have to do, again it is a first order reaction. I can write T50 is equal to 2.303, sorry it is 60%. T60% will be 2.303 by K log of 100. 60% is completed. How much will be left then? 40%. So it will be 40. Another T they have asked you is for 93.6 is equal to 2.303 by K log of 100 by 93.6 is completed. Then how much will be left? 100 minus 93.6, that is your 6.4. Okay. Now what you have to do, this T60 is given to you is 50 minutes. Take the ratio of both. So I can write 50 by T93.6 is equal to log of 100 by 40 minus, divided by log of 1000 by 64. Okay. So how you can solve this part? We can take it as 0 cancelled, log of 10 minus log of 4 whole divided by log of 1000 minus log of 64. So you know log 10 value is 1 minus log 4 is 0.602. Okay, and then here 10 log 1000 will be 3, and log 64 means 64 can be written as 2 to the power of 6, right? So I can write log of 64 as 2 to the power of 6, that is 6 times of log 2. So that is equal to 6 times of 0.3, or we can take 1.8. Okay, so 1.8, and here also for easy calculation we'll take it 0.6. So how much I'll get here if we solve this part? 1 minus 6 will be 0.4, 3 minus 1.8 will be 1.2. So you see here I got the ratio 50 by T93.6 is equal to 0.4 by 1, that is 1 by 3. So what I'll get, x will be equal to 150 minutes. Okay, so the correct answer for this question is option C. Not a difficult question, but little calculation is involved. Okay, next. So one more tip here, you should remember log 2 to log 9. These values, keep it in your mind so that calculations will be faster. Okay, and especially log 2, 3, 5 and 7. These values you must remember. Next, half-life period of a first order reaction is 60 minutes. What percentage will be left after 240 minutes? Okay, there are two ways of doing this question. If it is a PU question, you have to go for substituting it in the first order equation and then do. But when it is competitive, you can easily solve it by one method, that is 240 minutes are there and 60 minutes is given. So how many half-life is there? So total number of half-life is 4, right? So in each half-life, what will happen to the concentration? It will decrease by half. So we are starting with, we are starting with 100. Then in the first half-life, what it will become? 50. In the second half-life, it will become 25. In the third half-life, it will become 12.5. And in the fourth half-life, half of this one will be 6.25. So how much will be left? 6.25%. So the correct answer is option A. Okay. Next. A gives P, Q plus R, follows the first order kinetics with a half-life of 69.3 seconds at 500 degrees Celsius. Starting from the gas A enclosed in a container at 500 degrees Celsius and a pressure of 0.4 atm, the total pressure of the system after 230 seconds will be. Okay. So now this question is from your gas phase, little not different, but you have to understand how to write the equation. So first see here, A is giving us 3 gas, P, Q and R. Now just imagine when you are starting the reaction, just started, you have taken A. Will there be any P, Q and R formed at that time? No, right? So the initial pressure of A will be 0.4, P, Q and R will be 0. Okay, this is when you have started the reaction. Now at 230 seconds, after 230 seconds, let X amount of A has reacted. Then how much A will be left? 0.4. From that X amount has reacted, so left will be 0.4 minus X. How much A is reacting? Same amount of P will form, same amount of Q will form and same amount of R will form. Now we can write the equation for this A first order, K equal to 2.303 by T log of A naught by A. Okay, here we can see some calculation. Half-life is given and we know the for first order T half is equal to 0.693 by K. So what will be K value? 0.693 by 69.3. So this value will be 1 by 100, right? So I'll put in case of K 1 by 100 and 2.30, I'll just take 2.30 so that my cancellation part will be easy, and 230 seconds log of, what is A naught value? 0.4, and what is A value after 230 second? 0.4 minus X. So if we solve this part, I'll get this one as 1 by 100 again. So 1 by 100 and 1 by 100 is cancelled. So 1 is equal to log of 0.4 minus 0.4 minus x. 1 can be written as log 10. Yes or no? 1 can be log 10. So log of 0.4 by 0.4 minus x. So this log can be cancelled from both sides. So now I have this equation. I'll erase this side. So if you have seen, we have got already log 10 is equal to log of 0.4 divided by 0.4 minus x. So I can write 10 is equal to 0.4 by 0.4 minus x. If you solve, we'll get x is equal to 0.36. But what is the point of calculating x here? So the question has asked you what is the total pressure after 230 seconds. So what is the total pressure after 230 seconds? P total will be this addition of all these pressures. So I'll get 0.4, xx will get cancelled, 2x. So we can substitute x is equal to, so P total is equal to 0.4 plus 2 times of 0.36. So we will get 2 6 are 12, we'll get this one. So if you add this, we'll get 1.12. So the correct answer for this question is option D, 1.12 atm. So what mistake you could have done in this question? Generally, after finding x, if the option would have been 0.36, we'll directly mark it. We forget what is the question asked here. So the question is the total pressure. Okay. Next. Okay. Now another very important topic, half-life. Our first order reaction is half completed in 45 minutes. How long will it will take to complete 99%? So for this we have a relation. Again, from competitive point of view, you should know this relation. T 99.9 is equal to 10 times of T 50%. T 50% is 45 minutes. So we'll get 450 minutes, convert it into hours by dividing by 60. So we'll get 7.5 hours. So the correct answer for this question is option D. Easy one. Okay, next. Again, from the general equation, for the nth order of the reaction, half-life period is directly proportional. So you should know this, T half is directly proportional to 1 by a to the power of n minus 1. Okay. So the correct answer for this question is option C. From this formula, you please note it down, important one. Okay, so we can use this, some other numericals can be just solved by knowing this one formula. Yeah, this formula, this question uses that formula. Half-life of the reaction is found to be inversely proportional to fifth power of its initial concentration. So what it is telling? Half-life is proportional to fifth power of the initial concentration. What is the order of the reaction? Just now I told you T half is proportional to 1 by a to the power of n minus 1. So I can equate these two. Okay, so n minus 1 is equal to 5. So n will be equal to 6. So the order of the reaction is 6 and the correct answer for this question is option B. I'll tell this question is little tricky. Okay, not tricky means it is not, this formula is not very commonly known. So please note down this formula. Okay. Next. The plot of T half versus R0 for a reaction is a straight line parallel to x-axis. What does this mean? Whenever you are doing a graph and we are having a graph of T half versus R0 and the graph comes a straight line. So what does this indicate? It indicates that the T half is independent of R0. It doesn't depend on R0 at all. So we know this is true for which order reaction? For first order reaction. So if you know for first order reaction, T half is equal to 0.693 by K. There is no term for A0 here. So what I can say, the order of the reaction is first order. If it is first order reaction, then what is the unit of K? K unit will be, again you can, if you have not remembered, you can use this formula later, n minus 1 second inverse, but it is my suggestion that you should remember the 0th order and first order, the table, everything, their half-life, their integrated rate law, their graph, and then half-life formulas also you should remember. So if I substitute n is equal to 1, so in this case it will become 0, this will become 0, the unit will be second inverse, correct answer will be option D. Okay, next. In a first order reaction, the concentration of the reactant is reduced to 12.5% in 1 hour. When was it half completed? Okay, this is also very easy to solve if you know this trick. So first of all, what is telling? The concentration is reduced to 12.5%. So let us do first, if we start with 100. After first half-life, it will become 50. After second half-life, 25. After third half-life, it will become 12.5, right? According to question, this whole thing has taken place in 1 hour. Okay, that means each half-life, because it is a first order reaction, it is also mentioned. So each half-life will be equal. So 60 minutes divided by 3. So you will get 20, 20 and 20. So when it was 50%, when it there occur 20 minutes, the concentration become 50. So the correct answer for this question is option A. Okay. Next, half-life period of a first order reaction is 10 minutes. Starting with the initial concentration of 12 molar, the rate after 20 minutes. Okay. So first of all, what is the formula of rate? Rate is K into concentration of A. Okay. Suppose you want to calculate the rate after 20 minutes, you need the concentration of A after 20 minutes. Okay. So first of all, we'll calculate what is the concentration of A after 20 minutes. How to do this? Again, we'll use the half-life table. Since it is a first order reaction, 12 molar was there. In first 10 minutes, it will become 6 molar. And in the next 10 minutes, it will become 3 molar, right? So the concentration of A after 20 minutes is how much? 3. So I can put here K, A concentration is 3 molar. Okay, now how to put the value of K? We know for K is 0.693 by T half, right? So I can write 0.693 by T half is 10 minutes into 3 molar. So we'll get 0.0693 into 3. So you see, you need not solve it also. If you have solved only by up to 3 molar, you can easily see there is 2 options with 3 molar. So we can eliminate these 2 options and we can just check with A and D. So the correct answer for this question is option D. Now let us go to the next question. Arrhenius equation questions we have got. The rate constant K1 and K2 for 2 different reactions are given. Okay. The temperature at which K1 is equal to K2. Okay. So first of all, what is the K1 formula? K1 is equal to K2 and K1 given to you is 10 to the power of 16 e to the power of minus 2000 by T, and that will be equal to 10 to the power of 15 into e to the power of minus 1000 by T. Okay. Now take, just we can cancel 10 here. So I'll get 10 e to the power of minus 2000 by T is equal to e to the power of minus 1000 by T. Now take ln on both sides. So I'll take ln of this part, that is ln of 10 plus ln of e to the power of minus 2000 by T is equal to ln of e to the power of minus 1000 by T. So ln of 10 is 2.303 plus this one I can write minus 2000 by T, and this one can be written as minus 1000 by T. Now if I solve this equation, I'll get 2.303 is equal to 1000 by T, or I can get T equal to 1000 by 2.303 Kelvin. So the correct option for this question is option number C. Okay. So here little calculation is involved, but not very difficult one, easy to solve. Next question. Okay, so this is some concept based question. The rate of a reaction is given by this one under standard notation. In order to speed up the reaction, which of the following has to be decreased? So it is very well known that if activation energy decreases, rate of the reaction will increase. So from there we can easily tell the correct answer is option B. But we should also know what happens when T and Z. Okay. So if you see, K is equal to P into Z to 1 by e to the power of EA by RT. Okay. Now you see it is telling the which factor has to be decreased. So if T is decreased, what will happen to this ratio? Denominator is increasing. If T is decreased, then this ratio will increase. That means K value will decrease. So T cannot be the answer. Now what with Z? So K and Z are directly proportional. If you decrease Z, K will also decrease. So that also cannot be the answer. Now if you decrease EA, if only the activation energy is decreased, then this fraction will decrease. So that means I can tell this whole term will decrease. If this whole term decreases, then K will increase. Inversely proportional. So by that we can say EA or directly also we know whenever activation energy will decrease, rate of the reaction will increase. Next question. Temperature coefficient of the reaction is 2. What is the meaning of temperature coefficient? That means whenever you increase the temperature by 10 degrees Celsius, the rate doubles. Okay, that is the meaning of temperature coefficient is 2. When the temperature is from 30 degree to 90 degree, the rate of the reaction is increased by. Okay, very different question this one. We are going from 30 degrees Celsius to 90 degrees Celsius. Okay, so you have to tell here how many times the temperature increased in terms of 10. Means first we'll go 30 to 40, then 40 to 50, 50 to 60, 60 to 70, 70 to 80, and then 80 to 90. So 1, 2, 3, 4, 5 and 6. So we have increased the temperature 6 times by 10 degrees Celsius. So that is then what will be the rate. So here you have to take 2 to the power of how many times we have increased. That is 6 times. So 2 to the power of 6 is 64 times. So the correct answer for this question is option D. So this you have to little know what is done here. Next, which of the following statement is in accordance with Arrhenius equation? Okay. Rate of a reaction increases with the increase in temperature. We know this formula. K is equal to A into e to the power of minus EA by RT. So I can write this equation e to the power of EA by RT. Now see, if temperature increases, this fraction will decrease. The whole e to the power of that value will decrease and K will increase. So the correct answer is A. Okay, let us see the other options. Rate of a reaction does not change with the increase in activation energy. This is wrong. We know activation energy is a factor, so it will definitely affect the rate. Rate constant decreases exponentially with the increase in temperature. This is also incorrect. Whenever temperature increases, rate constant will increase. Rate of a reaction decrease with the decrease in activation energy. This is wrong. When activation energy increases, rate of the reaction will decrease, and vice versa. Okay, so the correct statement is option A. Again, a theory based question. The activation energy of a chemical reaction can be determined by. So we know this formula, log of K2 by K1 is equal to EA by 2.303 R T1 1 by T1 minus 1 by T2. Okay. So what does this equation is used for? This equation is generally used to calculate the activation energy. Whenever you see numericals also, this equation we always are asked to find the activation energy, right? So that is why this is done by evaluating the rate constants at 2 different temperatures. So the correct answer is option A. Okay, next. Which is a wrong statement. Again, so on the basis of effect of catalyst, I have told you in the effect of catalyst, you should know that what does a catalyst do? It increases the rate of the reaction by decreasing the activation energy. So rate constant K is equal to Arrhenius constant A if EA is equal to 0. Okay, this is also important statement. I have this formula, right? K is equal to A into e to the power of minus EA by RT. Okay, if EA is 0, then this whole term is 0, then e to the power of 0 is 1. So I can write K is equal to A, right? So that is why this statement is correct. Next, e to the power of minus EA by RT gives the fraction of reactant molecules that are activated at the given temperature. This is also correct statement. From the Boltzmann curve, we'll get the fraction of molecules that are activated is given by this fraction. Next, ln K versus 1 by 2 plot is a straight line. Yes, this graph is also there. If you see, if I take the ln on both sides, I'll get ln K is equal to ln A minus EA by R 1 by T. Okay, so if I draw a graph for ln K and versus 1 by T, okay, so what will be the slope of this equation? Minus EA by R, and the what is the y-intercept will be ln A, right? So you can see it is a straight line. ln K versus this is a straight line. Okay, next one, presence of catalyst will not alter the value of EA. So I have told you again and again, whenever we use catalyst, the activation energy decreases, as a result of which the rate of reaction increases. So this statement is incorrect. So the correct answer for the question is option D. Okay, so all statements A, B and C are correct, and we have to tell the wrong statement. So the correct answer will be option D. Okay, next. Okay, so we have reached the last question here. Higher order, so this question is from collision theory. Higher order reactions are rare due to. So we know collision theory speaks about two important points. That is, first of all, the collision should happen in proper orientation. Okay. And second factor, the collision should have sufficient energy. Right. That two things you have to remember. Okay, so higher order reactions are rare due to low probability of simultaneous collisions of all the reacting species. So when two species are there, they can react, but when we increase the number of species, so it is very rare chance that they all collide with proper orientation and also have the sufficient kinetic energy. So that is why the correct answer for this question is option C. Okay. So that's all for this video. We have discussed all 30 important questions from kinetics. So give more importance to rate law and integrated equations and Arrhenius equation for the complete revision of this chapter. Okay. And if you have found this video useful and informative, so please like, share and subscribe our channel so that you can boost up your preparation with such informative videos further. Thank you.